So today we'll be synthesizing a calcium channel blocker. And calcium channel blockers are used as antihypertensive drugs, which means that they can lower high blood pressure. And they're synthesized via the Buginelli reaction, which is a one-pot synthesis of an aldehyde, a beta-ketoester, and urea to form a 3,4-dihydropyrimidinone, which looks like this. And so in our case, our aldehyde will be benzaldehyde. We'll be using ethyl acetoacetate and urea. So some notes about the reaction. After adding the reagents, we'll collect about 1/2 ml of this initial reaction mixture to analyze by TLC later on. After that, there's a 45-minute reflux period, so be sure to note any changes during that time. After cooling and filtering, we'll TLC using a 1:1 hexanes ethyl acetate mixture. And then finally, when the product is dry, we'll be taking the mass, the melting point, and an IR spectrum.
Alright guys, so first we're going to measure out the urea. So we want to get as close to 0.75 grams. So I tared this little weigh boat here, and then we're going to see how close we can get to that. So we got about 0.768 grams, and then if you guys want to look, if you want to get a close-up, so this is what the actual solid looks like, so you can see it's a white powder. So now that we weighed out our urea, we're just going to add it to this 25 milliliter round bottom flask, and then also put a little stir bar. Here you can see we're measuring out benzaldehyde. We want 1.3 milliliters, and we're going to add this 1.3 milliliters of benzaldehyde to our reaction flask. Okay, so now we're going to measure out about 2.4 milliliters of ethyl acetoacetate. And lastly, we're going to add 5.0 milliliters of ethanol. So now that we added all of our reagents to our flask, we attached a reflux condenser, and then we also have a thermal well heater set up so that we can heat the reaction. But before we do that, just want to give you guys a close look at the reaction. You'll see that it's colorless and it looks clear. So in order for the reaction to proceed, we need to have acidic conditions. So here we have concentrated hydrochloric acid, and we're going to add 10 drops from the top of the reflux condenser. I'll show you guys a close-up of the reaction. You can see it's still pretty colorless, but it's just getting a little bit foggy. So before we start heating the reaction, we're going to take a couple drops so that we can analyze it by thin layer chromatography and compare it to the starting materials, benzaldehyde and ethyl acetoacetate. So I just took out a couple drops and I'm going to dilute it with 10 drops of ethyl acetate. So now we start to heat the reaction. We're going to turn it about 2/3 of the way. and hopefully in a few minutes the reaction will start to reflux. But in that meantime, we're going to analyze our TLC. So here we have three prepared solutions: the benzaldehyde, ethyl acetoacetate, and then our initial reaction mixture. So we developed our TLC using 50% hexanes, 50% ethyl acetate. And then here's what the TLC looks like once we've developed it and visualized using UV light. So on the first lane is benzaldehyde, and then ethyl acetoacetate, and then finally our initial reaction mixture. Okay, so now let's see what our reaction looks like. So this is after 15 minutes of reflux. You can see that it's starting to turn slightly yellow. And then we'll fast forward to 30 minutes of reflux. Now it looks bright yellow. It doesn't really look clear anymore. And then finally, after 45 minutes of reflux, it looks still pretty bright yellow, and you can see there's a lot of solid on the sides of the flask.
Did you put music in yours?
So now we took it off the reflux and let it cool for a bit. You can see that there's a bunch of solid at the bottom, and that should be our product. Our product should precipitate during the reaction. Alright, so now that we finished the reflux, we're going to put it on ice for about 15 minutes. And hopefully that allows all of the product to precipitate so that then we can filter it out afterwards. Okay, so after 15 minutes, we're ready to do our vacuum filtration. So we're going to wet this filter paper with a little bit of cold ethanol. So we're going to pour our product into the funnel, and it's a pretty thick mixture, so we're going to use our spatula to try to get as much of the solid out as we can. And we're going to use fresh ethanol to keep washing our flask to try to get as much of the product as we can out. So I'm just going to add about 2 milliliters of ethanol, kind of rinse that, try to get more of it out. Another 2 milliliters. So here's a close-up of what the solid looks like, and you can see there's still a little bit of yellow spots on there. So in order to get that out, we're going to use our final 2 milliliters of cold ethanol. And I'm just going to try to get the little impurities. So here's another close-up look, and now you can see that it's pretty much a white solid, and hopefully it's pure enough to analyze. So while our product is drying, we're going to do our final TLC analysis. So we got the 3 solutions from our earlier TLC, and then the 4th one is our isolated product. So we're going to develop it once again using 50% hexanes, 50% ethyl acetate. And here's what the TLC looks like. On the left, benzaldehyde, then ethyl acetoacetate. And then if you can compare the initial reaction mixture and then our final isolated product. And here's what the product looks like after it's been drying for a few days. You can see it's a white fine powder. So we transferred it to a tiered vial, and here's the isolated product mass, as well as the melting point. And then the last thing you need in order to complete your final report is the IR, which is posted on Blackboard.